Okay, for question number 1, it says, is the algebraic expression a polynomial? The answer is no. Polynomials cannot have, you cannot have these two things. No variable will have either a negative or a fractional or a decimal exponent. They have to be all, what kind of numbers?
Integers.
Whole numbers.
Whole numbers.
Okay, so these two are no's. So we're talking about the variable. The variable cannot have a negative exponent. It can't have a fractional exponent. You can't have a variable under a radical. You can't have something like this. No variable in the denominator of a fraction. You can't have absolute value with radicals, with variables. So these are all no's. Now, could you have something like this? I'm going to make that 14. Can you have that? Yep, you can. You can. But if I did that, no, you can't. So the variable, can you have this? Yes. I don't care if a number is fractional. I could even have this, which is 1/5. As long as my variables they have to be positive exponents. Now, what about, so this was no, number 1 was no. Is this graph a polynomial? No. You can't have breaks, sharp corners, you can't have holes. Now, anyone know what this function is called?
Exponential.
Not exponential. Look at this. What is this function called? This is the reciprocal function. This is the reciprocal function. What does it look like? So I violated the fact that you have a variable in the denominator. Plus the fact that there's a break here. You can't have breaks, sharp corners, curves. Nothing that looks like you can't have any breaks. That's not a polynomial. Neither is this. If I did something like that, that's got a sharp corner. Okay? So no on those. Number 3, how do you do synthetic division? What do you do? If I ask you to take this and divide, what would you do? Tell me. Put the opposite number outside. What goes inside? 4. What goes next? 0. Then what? Then what? Then what? So what do I do? Bring down the 4, multiply, add, multiply, add, then what? What do you get? 28. Then what? Then what?
Multiply.
And you get 69. So what is the quotient in the remainder? This is going to be 4x cubed plus 8x squared plus 14x plus 31 plus a remainder of 69 over x minus 2. This should be a plus or a minus sign, not a times sign. Number 4, is this a factor of this problem? You're going to plug negative, you're going to evaluate this for -1. So what is -1 to the 25th power? Minus -1 to the 20th power. Minus 2 times -1. So you're going to use your fact of, you take a negative and raise it to an odd power or even. When you evaluate this, you get -1, -1, and this is gonna be a pos, so -2, -1, -2, -3. Add these up, you get -10. So, is that a factor? If that were a 0, you'd say yes, but it's not. You say no, the remainder is -10. You could put it over x plus 1. Or you could have just wrote -10 is the remainder. Number 5. How do you do long division? Could I have done synthetic? No. Why not? Because the degree of this is a 2. So we have to do long division for this problem. Now, why am I putting a 0x squared right here as a placeholder? Why did I put a 0x here as a placeholder? So, what do I want to do? I want to get rid of 3x to the 4. So I need a 3x squared. Why? Because 3x squared times x squared is 3x to the 4. So when I subtract them, they're gone. So what is 3x squared times 0x? It is 0x cubed. And what is 3x squared times 4? 12x squared. Now what do I do with this? I subtract it. So that's going to go 2x cubed minus 0x cubed is 2x cubed. And what's 0x squared minus 12x squared? It's -12x squared. Don't forget to subtract the whole thing. Now you always bring something down. I'm going to bring down -6x. So I have to multiply x squared times what is going to give me 2x cubed. I need a 2 and an x. So I'm going to multiply 2x times x squared. I get 2x cubed plus 0x squared and then plus 8x. What do I do with this? I subtract it. These are going to cancel. -12x squared minus nothing is -12x squared. And -6x minus 8x is -14x. Bring down 4. So here I need a -12. -12 times x squared is -12x squared plus 0x and then minus 48. Now when you subtract, what happens? These cancel. You get -14x. This is going to become a positive 48, so when you add, you get 52. There's nothing else to bring down, so guess what this is?
Remainder.
That's your remainder. That's your remainder. So, let's answer our questions. It says, is this a factor of that? The answer would be no. The remainder would tell me if you divided correctly, -14x plus 52. Now, I want to see this. I may tomorrow ask you to just divide and write the answer. Instead of is it, I may just ask you to do the division part. And give, so how would you write this answer if I did that? It would be 3x squared plus 2x minus 12 plus a remainder of -14x plus 52 over x squared plus 4. That's how you would write the answer. Questions? Okay, next one, number 6. How many variables are in this picture? How many variables do you see in this picture? Variables. There's 2 variables. If I asked you, how many zeros do you see? This is a 0, this is a 0, that's a 0, and a 0. These are your roots. Your roots are your zeros. But you're comparing 2 quantities here, an x and a y. How would you write this in factored form? you're gonna write y equals, and you could write f of x, because it's a function. So either y or f of x. Now, in order, can you tell me how to write this?
X plus 2,
Mm-hmm.
X plus 2, X minus 2, X minus 1.
Now, if you would have seen something that looks a little different, what if it would have touched at one of these zeros? You have to have one, you'd square one of them, okay? What is the degree of this? It's 5. 1, 2, 3, 4, 5. This is a 5th degree polynomial. Questions? So, how many variables do you see? 2. You need to have 2 variables here, people. 2, y and x. Some of you did not do that. I could have marked it wrong. Next. I want a 4th degree polynomial and the zeros are at 2 and -1. Now, I don't have, this is just a polynomial. So you don't need the y in this problem. But because I gave you a picture with 2 variables, you need to represent it with 2 variables. So how do you write a polynomial? You could have done, if you would have done y equals x minus 2, that is okay. Or you could have had, if you didn't have the y, that's fine. You didn't necessarily have to have that. But there's other answers, and no one did this. You could have had this. Or you could have had that. Those are all 4th degree polynomials with zeros at 2 and -1. Those are all fine. It didn't say whether, it didn't, if it said it touches at both of them, then this is the only answer. If it says it crosses at both of them, crosses through, then one of these 2 answers would have been it. But I didn't give you any specifics, so any of these 3 answers work. Does everyone understand the difference? Okay, next one. A lot of you guys got this wrong. What would k be? There's 2 ways you could have done this. You could have evaluated this for f or x when x is 3. So 3 to the 4th power minus 5 times 3 cubed minus k times 3 squared plus 18 times 3 and then plus 18. What would I get if this goes into this? What would I get for a remainder? 0. So what you would do is evaluate this for equaling 0 using k as a variable. You're solving for k. So you should have gotten 3 to the 4th is 81 minus 135 minus 9k plus 54 plus 18 equals 0. If you combine all these and bring it to the other side, you get negative 9k equals negative 18, so k is 2. That's one way of doing this problem. The other way you could have done it is this way. You could have used synthetic division. You would put a 3 outside, a 1, a negative 5, a negative k, an 18, and an 18. This is how you could have done this also. So bring down the 1. 3 times 1 is 3, and add. Multiply. This is negative k minus 6. Then you multiply. Negative 3k plus 18. Or minus 18, sorry. Minus 18. Add. You get negative 3k. And then this is negative 9k. Add negative 9k plus 18. And then this would have to be a 0 remainder. So you could have done it this way also. Subtract 18 and divide, and you get the same answer. Whichever way you like. Questions? Yes.
So the final answer would be k equals 2.
K equals 2. Yep. Next, determine if 2 is an upper bound. First of all, when you test a positive number outside and you get all positives, that's an upper bound. So can a positive number be a lower bound? No. A positive number is either going to be an upper bound or neither. If you test a negative number and you get either a plus, minus, like that, or that, a negative number tested with alternating signs at the bottom tell you that's a lower bound. So a negative number can't be an upper bound. It'll be neither if you don't have that situation. So, if I ask you, is 2 an upper, it can't be, that's a trick question. So it's either upper or neither. So what you do is you test a 2, put a 2 here, and you do 1, 2, -7, and 20. If all these come out to be positive, so bring down that, multiply, add, multiply, and add, you get 22. This is an upper bound. These are all positive numbers. So it's upper. I want to see this work for a point, and the answer is upper for the other point. Now, let's talk about these zeros. Okay. So, what are real zeros? Real zeros are rational and irrational. We have a subset of numbers called imaginary. Imaginary numbers are numbers with, when you have a negative under the radical, like -2, which is root 2i. These are imaginary. So if I took these are called all. All zeros are real and imaginary. But I just want rational. Rationals are like 1, -1, 1/2, 1/3, 5/2, 3/4. These are all rational. Irrational are like square root of 2, square root of 3, square root of 5. And imaginary are with the I underneath the radical. So for this one, I only want these kinds of answers. No square root of 2. But it ended up being, if you do this problem, you have to use the rational zero test. And the first number that works was 1. 1 worked. Do you guys know how to do the rational zero test? You take plus or minus 1, plus or minus 2, plus or minus 4, 5, 10, and 20 over 1 and 2. Now the first one, always start with 1 and work your way up. And look for your upper and lower bounds to get rid of some problem. As soon as you find your first 0, it's going to knock down your degree 1. You want to get to it to be an x squared. So I tried 1, 2, -13, 18, 13, and -20. Bring down the 2. -11, 7, 20, and you got your first 0. So 1 is a 0. That goes there. What's this? 2x cubed minus 11x plus 7, x squared, 7x plus 20. So you start over again. You've got 20 and 2 for your terms. -1 worked. So you bring down the 2, multiply, you get 20, -20, you get 0. So -1 is a 0. That goes there. That's real. It's rational, I mean. They're rational. Now what's left? 2x squared minus 13x plus 20, and this factors, you end up with 2x minus 5 and x minus 4. This is just simply factorable, so 5 halves is a 0 and 4. These are rational zeros, 5 halves or 2.5 and 4. 5 halves and 4 points. Questions?
Can I see your work again?
See my work again? Sure. So 1 and -1 worked. Now, maybe you tried 2 and 2 didn't work. Maybe you probably would have found an upper bound. And you know that you can cross out, if you test a positive number and you end up with all positives below, which will eventually occur, you don't do anything bigger than that number. That's called an upper bound. Questions? John, are you good?
Yeah, thank you.
Okay. Number 11.
When you say bigger than that number, do you mean like negatives too?
Let's say I would have tried, the number, because this list is gonna get crazy.
Yeah.
Let's say I would have tried 5. If I had a 5 here, and these are all positive, 5 would be too big, so I'm not gonna try the 10, and I'm not gonna try the 20.
What I'm saying is, what if you tried -5 or -10? Like, would that be considered a smaller number? 'Cause you'd still mo-
-5 is smaller,
Well, I know it's smaller, but like.
Yes, if I tried a negative number, Teddy, if I
Yeah.
put a negative number here, and I got positive, negative like that, that's too small.
Okay.
Go the other way, try a bigger number. If you test a positive number and you get all positives here, it's too big. Try
Yeah.
something smaller. Okay, number 11. This wants the real numbers. So rational and irrational. So I test 1. I have 1, 4, -2, and -5. I bring down the 1. 1 times 1 is 1. Add 5, 3, doesn't work, right? So I'm gonna try 2. Actually, 2 wouldn't be a factor. Let's try -1. 1, 4, -2, and -5. Bring down the 1. -1, you get 3. -3, -5, and there we go. That was our first 0. So -1's our first 0. What is left here? X squared plus 3x minus 5. When you get to an x squared problem, you're going to use either the quadratic formula or complete the square. I would not complete the square when the middle number is odd. So -b plus or minus the square root of b squared minus 4ac all over 2a. So you get -3 plus or minus 9. 3 squared is 9. Minus 4 times 1 times -5 all over 2 times 1. This is going to give you positive 20, so it's -3 plus or minus root 29 over 2. What kind of zeros are these? They're irrational, but they are real. So you have -3 plus or minus root 29 over 2. Questions? Okay, number 12. I want all these, the rational, real, and I want you to factor. And I could ask you for all zeros. All zeros would be real and imaginary. So step 1, now I'm looking for 6 zeros. What do you see right here? I don't see a constant yet. So I'm gonna first factor an x out. One of my zeros I know is 0. One of them 0. So this, a 0 falls underneath, it's gonna be, this is a rational 0, it's real, and it's gonna be one of my factors, x times something. Okay, that's so far what I have. It's a big answer. Now, I need to break to 8 up. What are my factors of 8? I have a 1, a 2, a 4, and an 8 over plus or minus 1. So let's first try 1. Does 1 work? So if I tested 1, because that's what I would have done. I would have put a 1 out here, a -2, 3, third power, second power, first power, and constant. Why did I do that? Why did I put these zeros here? Placeholders, 5, 4, 3, 2, 1, 0. Bring down the 1.
It should be a -4 instead of a -2 for the.
Oh, I messed up. Okay, yeah, that should be a 4. Yep, 4. I copied it wrong. Right here, that should be a 4. Is it right now? Yeah, now it's right. Bring down the 1. 1 times 1 is 1, add. 1 times -1, add. 1, -1, add. -1, add. -1, add. I did not get a 0 remainder, so 1 does not work. Let's try 2. Let's see if 2 works. Now, where am I coming up with these numbers? These are my possible zeros. When you take the constant over the coefficient, the leading coefficient, and find factors, these are my possibilities. So bring down the 1, 2 times 1, add, multiply, add, multiply, add, multiply, add. Oh, and there you go. You have your 0. So 2 is a 0. So where does that go? Under my rational, and it's also real. And how am I going to write it? X minus 2. Like that, factoring this completely. What are these numbers right here? You're going to go 1 degree less. So it's x. I started off with a 5. This is going to be x to the 4th. Plus 0x cubed squared to the first power, and that's my constant. Oh, this is easy now. From here, I don't have to do any more synthetic division. This is called the difference of 2 perfect squares. X squared minus 2, x squared plus 2. Now, can you find any more zeros out of this? Absolutely. If you took x squared minus 2 and set this equal to 0, add 2, square root of both sides, what kind of zeros are these 2 now? There's 2 more that we have. What category do they fall under? They're real. So you write, are they rational? No, they're not. No, they're not. Plus or minus root 2. Now what about, there's 2 more zeros hidden here. Where are they? What are they? They're imaginary. So if you were to bring -2 over and take the square root, what do they look like? It's plus or minus root 2i. Now, I didn't have a category that said all zeros. If I would have said all, let me just write all, and all could say complex. These are complex zeros. You would have written 0, 2, plus or minus root 2, and plus or minus root 2i. If I would have had another answer that said all. It doesn't say all real, it says all. As in real and imaginary. Now, this factor completely, there's 2 answers I would have accepted. You could have done this right here. And I was okay with that, if you did that. Or another answer would be x minus 2, x minus root 2, it's really long, x plus root 2, x minus root 2i, and x plus, root 2i. Either answer is fine. X, this is factored completely, x times x minus 2. I'll take either answer. Once you get to irrational and imaginary, you can leave it like that. Questions? Okay, if the multiplicity of a 0 is even, what does it do? It touches. What if it's odd? Crosses. Last page. Okay, let's take apart this polynomial. First of all, is this behavior left odd or even? When they're opposite like this, is this going to be an odd number or even? Huh? Even means they both do the same thing. This is odd. When the left side goes down and the right side goes up, it's got to be an odd number. It's got to be odd. Now, I'm just writing odd. That's not the answer. So some kind of odd number. What's the least degree this could be? Why 5?
Because it's 5.
Because we have 1, 2, 3, 4 max and mins. So you go 1 degree higher, so it's 5. And that was the next question, or actually that was C, is if there's 4, the degree is 1 less, the degree, if there's 4 max and mins, the degree is 1 higher. If that's a 5, the max and mins is 1 less. So you can go either way with that. Now, is the leading coefficient going to be positive or negative? When the left side goes down and the right side goes up, it's positive. If it would have went the other way, like this, that is a negative leading coefficient. What if the left and the right side both go up? Positive. What if they both go down? Negative, and these would be even degree. Okay? How many inflection points are there? It's 1 degree less than the max and min, or you could go 2 less than the degree. So either way, that's a 3. What is an inflection point? It's the halfway, it's where the graph changes concave up and concave down. So it's always in between a max and a min. So there's 1, and there's 1, there's 3. Tell me the zeros left to right. -3, -2, 0, and 2. -3, -2, 0, and 2. Where did I get them? 1, 2, 3, 4. Now, it's asking you to write this in factored form. So you write y equals x plus 3, x plus 2, x squared. Why did I write x squared and then x minus 2? 2 reasons. Number 1, if you didn't have this 2 here, you're telling me that the degree is a 4. And the other reason is because it's touching there, so it has to have a multiplicity that's even. So you need that 2 there. Number 15, state the zeros in order as they appear left to right. So -1, 5, and 3. Then I want the multiplicity of each one. This is going to be odd because it's a third power. Odd. That number is a 4, it's even. And 3 has an understood 1 there. Odd. Now, I'm not asking you, is the 0 odd or even? I'm asking you, how many times did that 0 occur? That's the multiplicity. Now, tell me if it's odd, it crosses. If it's even, it touches. And odd crosses, that's what you should have had. I gave 1 point for each line. In the last two, we're gonna graph these. What should you, for 5 points, step one, I need the zeros. Factor an x out, you're left with x squared minus 4, and then that is the difference of two perfect squares. So I have a 0 at 0, at 2, and at -2. Now, what's the left and the right side? It's gonna look like that. How do I know? Odd degree, leading coefficients positive. So it's gonna cross through here and here. Now, how do I know how high up to go? And I wanna come down, and how do I know how low? And then I wanna cross, I wanna go up like that. That's what my left and right have to look like. What you need to do is pick one number between the two zeros. So I want to evaluate this when x, make a t-chart. When x is -1, you should get what? 3. I was looking for that. And if you put in a 1, you should get a -3. So this is what your graph should look like for 5 points. That's it. I want to see the left and right behavior. I want to see it cross through these, and I want to see some points in between your zeros. And the last one. What is the degree of this whole problem? 2, 3, 4. It's a 4th degree. And the leading coefficient's negative, so I need my graph to look like that. And the zeros are at 0, 3, and -2. And I know it's got a touch here at 3. It's gonna go like this. So what's happening is this thing's gonna be coming from here. You could have done this. You could have just done this for, I would have given you 3 points just by doing that. But how do you get the other two? You gotta plug in a number in between -2 and 0. So if you plug in -1, you should have gotten 8 for an answer. So this thing goes up to 8, right here. Comes down. And you only had to do 1 point in between, you didn't have to do both. But if you did 1, if you plug 1 in, you should get -6. And if you plugged in 2, you should have gotten -4. And you could just do the math on your own, and that's what a perfect graph looked like for this one. It had all the objectives, the left and right behavior, the multiplicity, it touches here, and it goes through each of these two zeros. It touched here, and it reached up at 8, and it went down to -6 and -4. These were each worth 5. Does anyone have any questions? Now, there were how many assignments? Your homework is due tomorrow. 4-1, 4-2, 4-3, and 4. There were 4 assignments that we did.